We are now moving from the initiation and onboarding phase of the PM lifecycle to the planning and organization phase. In this phase, the following domains will be discussed: detailed requirements, timelines and milestones, team and resources, RASI matrix, budget estimations, quality plan, change control, and deliverables and outcomes. My name is Egan Fajardo, and we'll be discussing detailed requirements. As a project definition moves from the high-level vision-oriented what definition of project requirements downward toward the technical how, there is a need to translate this into something more akin to a structured technical work definition. This translation process is reflected in the WBS box structure and embedded in the box definitions is both a requirement and a corresponding work relationship. A related value of this approach is that it serves as a good communication tool between the user's plain language requirement statement and the technical work required to produce those requirements. So, requirements. So, a requirement is a condition or capability that is required to be present in a product, service, or the sold to satisfy a business need. The requirements are classified as business, stakeholder, solution, transition, project, and quality. So business requirements describe why the project is being undertaken. Stakeholder requirements describe the needs of a stakeholders or stakeholder group. Solution describes the features, functions, and other functionalities that will meet the business and stakeholder requirements. This is further divided into the functional and non-functional requirements, wherein the functional describes the behaviors of the product, while the non-functional requirement describes the environmental conditions required for the product to be effective. Transition requirements describe the temporary capabilities needed to transition from the current state of the organization to a future desired state. Project requirement describes the actions, processes, or other conditions the project needs to meet. And quality requirements describe any criteria to validate the successful completion of a deliverable. On the surface, the process of defining requirements sounds pretty simple. Beyond the basic mechanics of developing project work units, there are several other scope-related issues that are not obvious in this process. We will describe these as the following abilities of requirements: traceability, affordability, feasibility, usability, producibility, maintainability, operability, scalability, simplicity, and sustainability. Each of these abilities represents a deliverable attribute that is likely not well defined in the original requirements, but presents a quantification that is needed for guiding the design. We will go through each of these abilities, but we will use a hypothetical project titled DoggyDex, which is a dog breed identifier tool to pepper our requirement discussion with examples. This serves as a continuation of the previous section on high-level scope and cost. So if you haven't watched that yet, please make sure to do so. The first set is traceability, affordability, and feasibility. Traceability is the ability to follow the life of a requirement through the life cycle, from its origins, to its specifications, to its subsequent deployment and use, and through periods of ongoing refinement and iteration in any of these phases. Affordability relates to a much of the design approach to the budget constraints. We should expect that there is always a pressure to cut design costs, but there must be a balance between costs and design goals. Third is feasibility. Feasibility is a term that can have many meanings in the project environment. The most obvious is the technical feasibility of the selected design approach. Feasibility can be thought of as anything that can get in the way of technical, time, or budget success, whether that be a technical item or otherwise. For our Dog Index project, for the traceability, it can be resolved by using a requirements traceability matrix or RTM, which we'll discuss later in this session. For affordability, since there might be a requirement that the device must have a bright screen, so the requirement may also specify to use a QLED display instead of OLED to lower the production cost. For feasibility, since there is a requirement that there should be a less than 3-second interval between recognize a, a dog breed, then the device might have a requirement that specifies that it must cache dog data to improve the loading and processing times. The next set of abilities is usability, producibility, and maintainability. Usability involves how the process or product functions in the hands of a future user. It is making sure that the product developed, whether a physical device, software, or website, is user-friendly. Producibility is an attribute related to how the actual item will be constructed. In many cases, there is a gap between the designer and the builder, so the key is to ensure that the building function is represented in the design process and probably even in the initial requirements. Maintainability deals with the item in production. This relates to the level of effort to keep the device ready to perform its function. For example, a machine might be able to jump tall buildings, but it might only be able to do so 10% of the time, the remaining of which is spent on maintenance. A trade-off could be either to do less maintenance work or be quicker in doing maintenance. Certainly, the best choice is not to ignore the issue. For our Dogitex project, for usability, the requirement might state that the button layout must be intuitive, natural, and must be a product from the focus group discussions. For producibility, uh, the management, the management or project management might want to have a manufacturer representative be part of the quality review group during the design phase, so that inputs on the manufacturing can be provided as part of the design. For maintainability, since since there is a limited since there's a limited set of available dog breeds as of the moment, then the device might have a requirement that specifies that it must have the capability to increase the number of recognizable dog breeds to support future breeds. The next set is operability, simplicity, and scalability. Operability involves the future user's ability to easily and safely use their product or device. Every specific device has a learning curve, and this requirement makes it easier and safer for the user to use it. Simplicity is an overarching concept. Complexity is a natural state. The goal is to find ways to achieve complex output as simply as possible. Simplicity is a motherhood term, but is a real management and design requirement. Scalability, on the other hand, connotes the ability of the product or process to handle higher levels of activity. For our Doggy Decks project, in terms of operability, the requirement may specify that the device must have a built-in tutorial mode. For simplicity, this would be on a management part, so the requirement must be transparent about assumptions, omissions, and context and any contextual biases to have an unambiguous understanding of the problem. For scalability, the requirement might specify that the online recognition service that the device uses must be able to handle 10,000 concurrent users without any noticeable performance issues. The last ability is sustainability. Sustainability is the least understood of the abilities. This term goes beyond all of the other attributes in that it evaluates the ability of the process or product to exist long term. It addresses concerns such as, will the technology survive, or will the design be functional for the required time frame? For our Doggy Decks project to have a sustainable requirement, the requirement might specify that the device must charge using a USB connection instead of a specialized plug. We should recognize that the requirement specification process generally involves trading off aspects of one ability for another. Seldom is the goal to maximize all of these. The challenge is finding the appropriate mix. Improper choices made at this point will follow the project through its life cycle. An obsolete, non-functioning, or hard-to-use project deliverable item decreases its ultimate value. There are various forms that we can use to manage requirements. Let's do a quick run on three of these. The first is the Requirement Management Plan or RMP. The RMP specifies how requirement activities will be conducted throughout the project. Second is the requirement documentation. The requirements need to be documented in enough detail to be included in the scope baseline and be measured and validated. The requirements documentation assists the project manager in making trade-off decisions among requirements and in managing stakeholder expectations. The requirements will be progressively elaborated as more information about the project becomes available. The third and last is the Requirements Traceability Matrix or RTM. An RTM is used to track the various attributes of requirements throughout the project lifecycle. It uses information from the requirements documentation and traces how those requirements are addressed to other aspects of the project. This form shows how requirements will be traced to project objectives, work breakdown structure deliverables, the metrics they will be measured to, and how they will be validated. This completes our discussions on data requirements. Our next topic shall delve on timelines and milestones. Thanks for listening.